Okay, so before we get started, I just want to go over really quickly the purpose of the unit circle. You guys have been finding trig values throughout this unit so far with your calculator. When you reviewed in 11.2 how to do application problems, you could do cosine of 45 degrees and you just type it right into your calculator. Or you could do the tangent of 32 degrees and you type it right into your calculator. The purpose of the unit circle is that there's some angles that you can find their trig values easily without a calculator. And so that's what we're going to be doing, is building this circle that helps us remember and memorize certain trig values. Not every single trig value is going to be able to be found without a calculator, but I'm going to help show you which ones can. All right. Now, let's go ahead and just get a little bit more workroom here, and then we're going to go ahead and start this. I just copied these circles or triangles, over here from what we did on the last page. Okay, so I have a coordinate plane here where this is my x-axis and this is my y-axis, and I'm going to take this 45-degree triangle that we made, and I'm going to put it right on top of this axis, right at the origin. Okay, so I'm going to take that and I'm going to put it right here. So there's that, there's the 45 degrees, and there's the 45 degrees, and there's root 2, comma root 2, and root 2, comma root 2. So I literally just took that special right triangle that we grabbed from the last page and I put it in the first quadrant, okay? Now, if I wanted to find the coordinate point that's right here at the end, right? The coordinate point is how far right I went, that would be its x-coordinate, and then how far up I go, that would be its y-coordinate. So to get to this coordinate point right here, I went to the right root 2 over 2, so that is its x-coordinate, and then I went up root 2 over 2, so that would be its y-coordinate. Okay. Now I could take that triangle and I could go in the second quadrant too. Let's say I put that triangle right here. This is 1, this is root 2 over 2, and this is root 2 over 2. Okay. So if I'm starting at the origin here and I want to now find the coordinates of this point right here, I go left root 2 over 2. Now in a coordinate system, if I want to go left, then I would need a negative on my x-coordinate. So negative root 2 over 2. But then I go up root 2 over 2. So the coordinates of this point right here would be negative root 2 over 2, comma root 2 over 2. I'm going to keep doing that in both of the other quadrants. So in the third quadrant here, here's my same 45, 45, 90 triangle. And I draw it again here. Okay, so the coordinates of this point here in the third quadrant, I go left root 2 over 2, and then down root 2 over 2 to get to this point, which would give me an x-coordinate of root 2 over 2 and a y-coordinate of negative root 2 over 2. The x-coordinate is negative because I went left, and the y-coordinate is negative because I went down. And then our last point for this part would be this one right here, where I would go to the right root 2 over 2, but then I'd go down root 2 over 2. So it would be here at root 2 over 2, comma negative root 2 over 2. Okay. Now, if I'm looking at this, this looks like way too much information. How is this supposed to be helping me? Well, let's get out some of the information that we don't need anymore. Okay, so if I were going to take this, and I'm just going to draw a smaller one because we're going to have less information, and I wanted to rotate 45 degrees on a radius of 1, okay, so that's 45 degrees. We just proved that the coordinate point right there would be root 2 over 2 and root 2 over 2. Okay, now I want to start at 0 degrees always when we're on doing our rotations. Okay, so how much would I rotate to get to this point right here? Well, I have a 90-degree rotation, and then if I want this 45 to be left over, and these are complementary angles, they add to 90, that would make this also 45. So this 45 plus this 90 would make this angle of rotation 135 degrees. So that would be negative root 2 over 2, comma root 2 over 2 for 135 degrees. Okay, now to get to this one, I'm going to rotate 180 plus 45, so that would be 225 degrees. And then our last one that we dealt with that has this, no, that's not the right one, JK. Just get that out of our way for a second. Okay. This one here, the rotation would be a 360 minus 45, so 360 the whole circle, but go back 45. So that would be 315 degrees, would be at this coordinate here. Okay. So let's just pause there, and we'll talk about how and why we use those numbers.